All right. So, the warm-up question, after I take down the board.
I already accidentally turned it off before. I was writing that. I was on my hand for the thingy, and I hit the black, the cord.
All right. So the warm-up question is kind of a basic version of what we're doing for today. And so this is an ACT question. Sorry, it's smaller than I thought it would turn out. It's the ACT practice question that I pulled, and I thought it'd be a good one to talk about because this is really kind of goes closely with what we're talking for today. So average rate of change. So Brianna went hiking. Brianna's altitude in meters above sea level is shown as a function. What's the approximate average rate of change from the 7th to 11th hours? Now, average rate of change is really just asking about slope, but we can't technically take the slope of a curve. So what we basically do is kind of make that like just a straight line between the two and find the slope between those two. And sorry, I did a copy of a copy so that the points are kind of hard to see. So you might have to do a little bit more estimation than you'd like to, but I'll try to help you see where they are. So we're going to 7th to 11th hours. So 7 hours, we're at about 65. 11 hours, we're at about, it looks like 105. And actually, that's a pretty straight line between the two. That's probably not the best example in that way, because even if it was like if I was going from like here to here, I would still draw a straight line and kind of ignore like that dip between those two. So essentially what we're doing is just finding the slope. So when they talk about average rate of change, and like I said, I pulled this from an ACT practice test. So average rate of change or slope, stuff like that shows up on the ACT. Those of you guys who are taking that soon, or taking it again maybe. So we're basically looking at the slope between those points. Oh no, it should be 7. Sorry, I don't know why I wrote 6. Just to keep you guessing.
It's okay. I want to figure it out.
No, 7, not 5. Gosh. All right. So I know it's gonna be really cold today, so I wore a really warm sweater, and then now I'm on fire right now. It's really warm.
That is cute.
Thank you. It's comfy. It's really soft and warm, but now I'm really warm. So 105 minus 65, the rise over the run. So end up with 40, over 4. And so that means she's going up 10 meters per hour.
What if like the line you draw is like wrong? Like these points, these like answers are so close.
Yeah, these are pretty tough like choices because I actually did what I just did in the when I was showing you guys. I actually made that 6 when I was actually doing this myself, like when I was checking my answer.
Mm-hmm.
And my answer, I don't think these were great choices of bad answers. I guess is probably so. The ACT is pretty good about trying to get your answer wrong if you totally let's say you flip that, they would have that as a choice. So these are probably not the best choices ever, but it happened to be what was my question already. So I was actually going to change the answers based off of all the mistakes I was making when I was writing this, but yeah, I typically they're pretty straightforward. It's not just because you were just a little bit off on your coordinates or whatever.
Okay.
Like if you called it 64, that's probably not one of the choices, I would guess. Maybe it is, but. All right, so we're gonna talk about this average rate of change today. Basically, average rate of change is the slope between 2 points. But we're talking about curves now because we're in pre-calculus. So we have to talk about curves rather than just straight lines. So since it's a curve, what we do, if you look at the little curve that they have drawn there, that f of x, they have a line drawn, and they call it a secant line. So a secant line hits a curve in 2 spots, and it basically is a straight line between those points. So they ignore that little bump. Now, it's the average rate of change. It's not an exact science. So this is not like where we're saying that's the exact slope between there. Again, we are taking out some of that. And again, going back to the warm-up, if I asked you for the average rate of change, like from like here to here, that would make a bigger, you know, like that would be a big like lump we're missing versus the one we did. So understand that this is not something that is going to be 100% like accurate if we're actually trying to find that slope, because we can't technically find it yet. So, so essentially, again, it's the slope. Now they're going to write this a little bit different than we've seen before, because we're used to slope being y2 minus y1 over x2 minus x1. Again, we're in pre-calc now, so we have to make it look really fancy. One of the ways they show is they write this as, does anyone know what the little triangle means?
Delta?
Delta, it is delta. And delta means change. So the change in y over the change in x. So how much x is different and how much y is different, we're just dividing those. So yeah, we use that. Where'd you learn that, Stone?
Chemistry.
Oh. So I'm trying to think of what class you would have had for math that would have had it, but yeah.
Maybe chemistry guy. Right, Snow? You're gonna be a chemist?
No, I hate it.
I thought it wasn't bad.
All right.
I just don't.
Another way they might show this formula, rather than calling it y, just like we've talked about, we also can call it f of x. But hopefully you guys have gotten used to it enough to realize f of x is just y. So the outcome when I put that x2 in, the outcome when I put the x1 in. So all of these different formulas are kind of ones you might see today. And again, the average rate of change, we're really finding the slope of this secant line. And the secant line is basically a straight line that cuts this curve. So like it just kind of goes, like if we could make a ramp from point to point, if that was our curve we are walking up or hiking up or something. So So it hits our curve twice, it's just a straight line that goes through that. So they might mention that secant line. So just kind of showing you guys how this looks. And again, this today hopefully should not be too difficult. There are a few little notation things that are just you're getting used to those, or we'll get used to those. So finding the average rate of change in our f of x here, our equation. The first one says from -1 to 1, and then it asks from 2 to 4. So we'll start with -1 to 1. So we have to figure out is basically what the function equals for each of these values. So I'm going to have to evaluate that and figure out those values. So substituting this in, just be careful with the negatives and the exponents. Probably should move this one because -1 to the 4th is just 1. But this is going to be -1, -1 to the 3rd is going to be -1. And then to do the same thing with +1. I believe we get 3 there. So what we're going to do is basically take, because it's a larger number, I'm going to go 15 minus 3 over, and then, because that's my outcomes, over the x values in order. So the 15 went with -1, the 1 went with 3, so my average rate of change from those points would be a -6. So if you guys want to try letter B there, as you're doing that, I'm going to pull up the graph for this so that you guys can see what the graph looks like to kind of show how this connects. Our graphs. So going into this, it's like -1 to +1, -1, +1. So understanding, it was a downward 6 rate of change. From 2 to 4, what happened?
0.
You should have gotten 0. So there actually was no change from 2 to 4. Again, this is an average rate of change, so you're like, yeah, there was a big change. It was like this big dip in the graph, but just because we're looking at just from 2 to 4, we're looking at that 2, 4, kind of like 2 snapshots in time. So if I looked away and then looked back 2 minutes later, you'd be back at the same spot. So in terms of average rate of change, as weird as that is, it is just 0 in that case. If we didn't get 0, I'll show you guys real quick how we get 0, hopefully. So what'd you get for x equals 2? What'd you get your value for x equals 2? So that was 0. So yeah, that's right. So x equals 2. The f of 2 would be 0. And then the f of 4 is also going to be 0. And again, just be careful with those signs. So if you aren't getting 0 for that, so then our rate of change is 0 minus 0 over 4 minus 2. It's just going to be 0. 0 over anything is just 0.
Don't we go in order? So
What's that?
when we go to order?
Okay, so real quick. So the order, as long as you're consistent, doesn't matter in the one problem. So I went this way.
Okay.
It doesn't, it doesn't really matter. I just usually try to pick the bigger one if I have a choice. And since the zeros were the same, it really didn't matter. That's a good point. All right. Now, over the interval from these inequalities, this is just asking for the same thing. It looks like it's way fancier, like real complicated. It's just saying from 0 to 3. So in this case, whoops, it's just saying, so x is 0 to x is 3. And then this one's just saying x is 3 to x is 5. So the inequality is not any more complicated. So I'm going to let you guys work on those if you want to try those.